Alright guys, I really hope you're watching this video because you got a test tomorrow. First thing, I know even the title at the top says Special Right Triangles Review, but this covers Pythagorean Theorem, Special Right Triangles, Geometric Mean. So for most of you, first of all, if you're in your spirals, you need to be going anywhere from about page 30... Let me double check it real quick. From around page 36 to 42 covers all this material we've looked at. Okay? You will have some formulas. You will have the formulas for the special right to make sure you have the two. And you'll have basic Pythagorean theorem, which I mean everyone knows. But so just be aware as we go through this. Number one, find n. This is a special right triangle, and you know specifically because of the units, the angles there. So first thing, our pattern, x, 2x, x squared of 3. Okay? So as we mentioned a few times before, and I've said in class, with these patterns, if there's a number there and you're trying to find missing things, you can literally take the pattern. By the way, I got some new pens, so the writing should be a lot better on this video. You can literally take the formula, set it equal to the value or the number that's there. So like here, you would have x squared of 3 equals 10 squared of 3. This one, when you divide, that's going to cancel out, and literally x is 10. But most of you know, if you have a number squared of 3 on that side, that number is the x, right? But they want you to find n, which is 2 times x. So always remember to actually answer the question that they ask. We say this all the time. I say this all the time. 2 times 10 is 20. Number 2, this is the 45, 45, 90. These two sides are congruent. This is x squared of 2. Kind of a similar thing here. If you were to literally set it up as a problem, x squared of 2 equals 7 squared of 2, but those cancel out through division, and it's just the number in the front. So x is 7, y is 7. Those are two easy versions of the problem. I'm sure as we go through, we'll find some not quite. Also, you can do Pythagorean theorem if you have two sides. They are still right triangles, but on those we didn't have two sides yet, so we have to see as the problem goes. 3, a 24-foot ladder is leaning against a building. The foot of the ladder makes a 60-degree angle with the ground. That's my drawing, that's not the pen. 24-foot ladder leaning against this is the building, right, whatever it is. How far is the ladder from the base of the building? They want you to find that, okay? So that makes, in our pattern, because that's 60, that's going to be 30, so that's x, 2x, x square root of 3. Again, wherever you have a value, you could always just put the pattern equal to what they give you. Most of you see this pretty easily, but again, if you want to set it up so you know what you're doing, and then this is a simple x equals 12, and that actually will be the length from the base to the ladder, right? So that's that. If you needed this, it would just be that. Now, a couple other things. Again, it's not all special right. What type of triangle does the following side lengths create? A squared plus b squared. Compare it to c squared. 7 squared plus 10 squared is 49 plus 100, 149. 15 squared is 225. Comparatively, 149 is less than 225, right? So remember, let's see. Equal means right. Greater than means acute. Less than means obtuse. 49 is less than 225, so this is going to be an obtuse triangle. Need to remember those two, okay? Those will not officially be on the formula chart. Need to know those. Find the value of x and y. Looks complicated. Don't freak out. You want to start one at a time, and the only place you have a number to begin with is the 14. Okay, so for the moment, we're only going to focus on this triangle to begin with. Okay? 2x, x, x square root of 3. Again, pattern, number, set them equal. X is 7. By the way, you're finding x and y, so you found the first number. Now, these two triangles are connected. It's also an x, so that's a 7. Now look, it's a 45, 45, 90. We're going to look at this triangle next. Okay? We didn't even need to find that side, by the way. No problem. It's not a part of what we need to find. In this pattern, you get x, x, x square root of 2. If this is 7, this is 7. Do I need to find this length? No. If you do, it's not a big deal, but you don't need it. So now down here on the last triangle, it's a 30, 60, 90. My x is 7. I'll put a 7 right there. Get rid of that kind of weird one. And again, the pattern is x, 2x, x square root of 3 for the y. If x is 7, you literally just put it there, and y is 7 square root of 3. Again, seems complicated, but if you understand the way the pattern works and how to put things in or solve for it, it should be really easy. Okay, we'll move up here. Number 6, a kite string is 150 feet long from the kite to the ground. And that is, it is the length of the kite string, make sure you realize that, 150 feet. The string makes a 45-degree angle with the ground. It's already written there about how high off the ground is the kite. So we'll use a variable. We'll call it m to be different. Okay, or, wow, obvious choice would have been h, wouldn't it? Height. Pattern, 45, that's a right angle when you go to the ground. So 45, 45, 90, xx, x square root of 2. Pattern, number, x times the square root of 2 equals 150. In the process of solving, you divide by the square root of 2. There is a shortcut to this I'll talk about in a second, but we'll go through the whole process one more time, because I know a lot of you we did that last week and y'all got it. Can't leave it like this. Got to do this. Denominator over itself represents 1. On the top, you have 150 square root of 2. On the bottom, these combine under 1. 2 times 2 is 4. Square root of 4 is 2. And there's a square root of 2 in the back. I got to come over here. Divide that, you get 75 square root of 2. And that's the answer for both x's, both here and here. 75. Right? That's both the x's. Remember the shortcut, because if you look at what winds up happening at the end right here, literally because the square root of 2 is here, if you divide 150 by 2, you get 75. You put the square root of 2 behind it, and you're good. Same thing, right? Find JL, JK, and KL. So JL is right here. We'll call that A. JK is right here. We'll call that B. KL is right here. We'll call that C. Now that I look at that, it probably will make more sense to do it this way, right? Since that kind of lines up with how we measure it. But those are the three sides they wanted me to find. Now, what do we start with? We have x, x, x square root of 2. Take the pattern, set it equal to what's there. Most of you realize really easily those cancel out. This is just 4. So it's 4 here, 4 here. Now for the 30, 60, 90, there's a spot on this. So it's not even the pen. The pen's working fine. There's a spot on my iPad that is just wonky with the way it works out, but everything else is cool. So you got that. So we know X is 4 now. So to find, well, first of all, that's JL, right? That's the first one. JK, the hypotenuse, is 2 times X, so 2 times 4, of course, 8. And KL is the long leg, and you just put the 4 in there, so 4 square root of 3. Find the height of the Eiffel Tower. Leave the answer in simplest radical form, which we should be doing anyways unless multiple choice gives us decimals. So in the pattern, we have x, 2x, x square root of 3, number, pattern, set it equal, divide by the square root of 3. Now this one, well, let's just go through it. Because of the numbers not being as divisible. So this one's going to be times the square root of 3 over 3. So 400 times the square root of 3 on top. That was just me getting a little messy with my writing. 3 times 3 on the bottom combined to 9. So you have 400, I did it again, square root of 3 over 3. And basically you're going to have to leave the answer like that. Because if you divide 400 by 3, you get 133 1/3, which ironically, even though you can write it as a third, gives you a decimal that repeats. So best to just do it like that. But again, the shortcut, take the 400, divide it by 3, put that square root in the back, and it gets you the same thing, right? All right, that's the front page of the review. And just a reminder, and I'll remind you again at the end of the second page, a lot of these questions are going to look like the exact same question on the test. But do not remember these answers because the numbers are being changed. Not all of them, but not all questions match exactly 1-to-1, but a lot of questions will have the same picture, the same basic question, but the numbers change. Don't memorize these answers, memorize the process. All right. I got to do this one too. So, can I undo that? Yeah. So give me a second to, there we go. All right, number 9. Joe Bean regularly takes a shortcut across Mr. Wilson's lawn instead of walking on the sidewalk on his way home from school. How much distance is saved by Joe cutting across the lawn? So he goes from here, or he cuts across. So his regular walk is 12 plus 30. He walks 42 feet. If he takes the shortcut, then we have to figure that out. It's 12 squared plus 30 squared equals c squared. And type that into your calculator. Type 12 squared. 12 squared plus 30 squared equals 1,044. And when you square root that, you're not going to get a whole number. You'll get a decimal. Now, the good news should be that you don't have to worry about simplifying this. I know we always say we don't want those decimals, but I'm pretty sure on the test, if there's a question like this, it's multiple choice. So we need the decimal because we need how much is saved by walking across the lawn. So this is not the answer. 32.3 is not the answer to the question. You have to take the 42 from going all the way around the sidewalk and minus the 32.311. And if you do that on your calculator, you'll get a decimal. And again, the multiple choice is probably either going to make you estimate it to the nearest whole number, or they'll give you decimals. So, I know for the most part we tell you not to use decimals, But if it's multiple choice and those are your options, you gotta use it. So, and this comes out to about 9.689. So, however the answer is written on there, if you left it like this, I'd be completely okay with it. But it should be multiple choice. Do the following side makes do the following side lengths make a Pythagorean triple? Yes or no? This is, does a squared plus b squared equal c squared? It's not acute, right, or obtuse. It's yes or no. Okay, so that's the first part. So you got to test each one out. 3 squared plus 4 squared, 25. 5 squared, 25. Are they equal? So that's yes. Let's see. We'll go green for yes, red for no, right? 7, 24, 26. 7 squared. That's the pen again. 7 squared plus 24 squared is 625. 26 squared, I've already done the numbers, that's why I know these answers, are 676. Not the same number, so that's a no. Okay? Last one, 8 squared plus 15 squared is 289. 20 squared is 400. Again, not a match. So Pythagorean triples, does a squared plus b squared equal c squared? It's a yes or no. Yes if they equal, no if they don't. 11, indicate the length of AC in the picture below. AC is the hypotenuse here. This is a 45, 45, 90. You know because it's isosceles, because 4 and 4. So literally it's just find that, and if you know your x is 4, the answer is literally put the x in front of the square root of 2. 4 square root of 2. Man, come on, write better. Write it all. And it's as easy as that. It's literally don't overthink it. So this one on the paper, there's a typo. I changed it on here before I went. I was intending for you to do a different type of problem, and then we used the wrong picture, so we'll just use this as a Pythagorean theorem problem. That's your B, that's C, and that's A. You can do it as a Pythagorean triple or just do basic Pythagorean theorem. So it sets up like that. 21 squared is 441. Yeah. And then 35 squared is a number. I need a vamp. 1225. So subtract the 441 over. You get 784. And the square root of 784 is the wrong number I typed in, sorry. 28. Okay, there you go. 13, find the area of the triangle. Area is 1/2 base times height. So as far as the formula goes, you need base, you need height. The base is already given to you. It is the 32 feet. Okay? It's this. What you're going to have to find is the height. So because this is an isosceles triangle, and you draw that altitude, these will break up the 32 into half, 16, 16. So to find height, again, you can do another Pythagorean theorem. 16 squared plus 8 squared equals 20 squared. So that's 256 plus 8 squared equals 400. Subtract the 256, 8 squared equals 144, and you get 12. Again, not the answer. That's 12. So now the formula is 1/2 times, not 16, sorry, times 12 times 32. 0.5 in the calculator usually works a little bit easier than making yourself write out a fraction. Not that it's a huge deal, but as a total, you should get 192 square feet. Find the length of EC, number 14. So a couple things. This is a rectangle. Don't forget that that means AB and DC are equal, AD and BC are equal, not then the whole lines, right? So what we're basically going to have to do here is find Pythagorean theorem twice. We'll start here with A, B, and C, and once we find B, it's also going to match it down here. Now, for what it's worth, this is a Pythagorean triple. I mean, obviously it is because it makes a right triangle, but it's one you should know. So if you know what it is, you can skip this little part, but you're going to have to do Pythagorean theorem otherwise to find B. So 5 squared plus B squared equals 13 squared. 25 plus B squared equals 169. Subtract the 25. B squared equals 144. Square root B is 12. So that's 12, that's 12. Now to find EC, we'll redo this as a right triangle ABC. And so now I have 12 squared, because it matches AB, plus B squared equals 20 squared, the C. 144 plus B squared equals 400. Minus the 144, you get 256. Square root, and it equals 16, and that's the length of EC. All right, and then the last two questions, this is geometric mean. Again, this is in your notes. This is somewhere around page 37, 38. It's the page after Pythagorean theorem. And for the most part, the two we look at are the pretty simple ones. Yeah, so this one, the geometric mean, this is proportion, diagonal to itself. These fill in the other two gaps, 6, 9. Cross multiply, square root. Can't keep it square root of 54, don't get a whole number. Breaks up into 9 and 6. Square root of 9 is 3, square root of 6 stays. That's your answer. Okay, geometric mean. Number 16, how tall is the building? So again, Pythagorean theorem, but instead of an x there is a number. Now, we're going to put a variable here at BD, and that's not going to give us the height of the building. Don't forget the height is this. Once I find this x, I need to add that 5 to it. Now, the 15 there is the geometric mean. It's the altitude. So just like in the previous question, even though it's a number, it goes diagonal to itself. The 5 and the x fill in the other two gaps. Cross multiply. 5x equals 225. Divide by 5, x equals, is it 45, I think I said? Yes. 45 is not our answer. You must add it to the 5 feet to get the whole building. Okay? All right. That is the review. I know it was kind of rushed this week, but again, need to be working. Hopefully you've watched this video. I'm going to keep an eye tomorrow morning on how many views it gets. Not just because I'm a vain YouTuber who wants clicks and for you to smash that like button or the bell or whatever. Because I need you to get good grades and pass and get to work. Bye.